All right, so we said earlier that one of the big goals of organic chemistry is synthesis, and synthesis is the creation of new compounds. And so these compounds can be either new drugs, new materials, new ligands. Think about inorganic chemistry and other stuff as well. So it's all about being able to control and make new compounds that have new properties so we can make new things, right? That's what humans are all about, making things do what we want them to do. And in order to do that, we have to understand how everything functions, right? We can't control the rules of nature, but once we understand them, we can manipulate them to make nature do what we want it to do. And so here's just kind of a reaction pathway. I just pulled this off of Google. So you can see they start off right here in this relatively simple compound, and then they do a bunch of different reactions, right, going like this to finally get to their kind of more complex product, right? And so there's a lot of different functional groups here that we haven't touched on, and a lot of stuff that we haven't touched on, but I just kind of want to show you an overall reaction here of a synthesis. You can tell some of these they only want specific enantiomers. That's why they have these wedges and these dashes. And then it's pretty cool too. I picked this one because it also shows the crystal structure. And so remember, when you're looking at this image on the right, you want to be able to picture what it looks like in 3D. This is an extreme example. You won't have to know anything this complicated or even close. Another cool thing I like about this one right here is they give you the percent yields, right? So some reactions, 84%, that's really good. So most of what you put in, you get back out. But then you can see other reactions are a lot more difficult, right? This one's kind of 6%. So if you put in 100 moles of this stuff, you only get 6 moles of product. And so, yeah, understanding carbon is what it's all about.